Greetings and welcome back. Here we are again with more algebraic expressions. This time we are going to be evaluating them. So just to refresh your memory, an algebraic expression is a mathematical expression involving at least one of the four operations where one term must be a variable. So we are talking about variables that represent unknown quantities, and then we'll also have some other calculations we have to do. So new to this video is these last two bullets down here, where we are going to be talking about evaluating, where you find the value, you find the value of an expression when a quantity is given for the variable. So we have an expression that contains a variable, and then we are told substitute at 2 for x or something like that. So another word you'll hear quite frequently is substitute, and that just means to replace a variable in an algebraic expression with a value given. So as we're going through this and we are evaluating these expressions, the order of operations is going to be really important. So I pulled back the order of operations pyramid just to refresh that. As we're solving, we're going to be starting with the parentheses, moving into exponents before we get to multiplication and division, where we go from left to right. And then same thing with addition and subtraction, left to right. So this order is going to be very important and plays a big role in calculating these accurately. So first up, we are going to be evaluating x plus 5 when x equals 9. So there's some really key things that you need to do when recording your work that set you up for when we get to solving algebraic equations. So keeping your work organized will keep your work accurate and help you identify if you've made a mistake. So as you go through this, we are going to get in the habit of recording the work vertically. So here we will write out, I always encourage you to rewrite the expression, and then we're going to be substituting 9 in for x. So that means we're going to be replacing that x with the value of 9. So we're left with 9 plus 5, and that equals 14. So yes, that one's quite simple, but they will become more complex. I just want to show you some of those foundations of this type of thinking. Next, we're going to evaluate 30 minus y when y equals 6. So I'm going to rewrite it, 30 minus y, and now I'm going to be replacing or substituting 6 in for y. So 30 minus 6 is 24. So again, you can see this is kind of like our pizza method when we did order of operations, and that is the goal. Work your way down. Next, we're moving into multiplication. So if you notice, this is addition, subtraction, here's the operation, multiplication. So 8p is the same as 8 times p, and we're substituting 7 in there for p. So you can write this a couple different ways. If you write it using the multiplication dot, you could then write 8 times 7 is 56, or this with parentheses is an equivalent way of writing that. You would 8 times 7 is how you would read that. So they have the same meaning, but they just look a little bit different. And you'll see that often in algebra especially. It just kind of simplifies your expressions. Next, we have what looks like a fraction, but we actually know that this is algebra for division. So we have q divided by 10, and we're going to be replacing or substituting that q with a 60. So 60 divided by 10 is 6. So notice that even though this kind of looks like a fraction, I'm definitely going back to that way of thinking that our numerator over a denominator is the same as a numerator divided by the denominator. So you can interchangeably go in one direction or the other with that type of thinking. So here we have a couple that are a little more complex. And so the value that we're substituting is 20 in for q. So I'm going to rewrite this, 4 plus 2 times 20 divided by 11. Now, in this one, we have our big bar, our fraction bar. And this big division bar here means that we are dividing everything that is above that bar. So before I can divide by 11, I need to evaluate the whole numerator first. So as I write this, I am going to keep track of my work vertically again, and I am going to follow that order of operations pyramid, where we have parentheses, exponents, multiplication and division, addition and subtraction. So first we're going to do the multiplication. 2 times 20 is 40. And then I'm going to rewrite all of that. Next, because I want to divide both of those, I want to divide the sum of those by 11, I need to do 40 plus 4, which is 44, divided by 11. And 44 divided by 11 is 4. So as you can see, the way this is written is essentially the same as 4 plus 2q divided by 11. We want to make sure that we do all of this here, all of those calculations, and then divide last. So this does look a little bit different than our other example here, where you notice that division, we are only dividing the product of 11 and q by 4, and then adding it to 25. So this is very different than 11q plus 25 divided by 4. These two expressions are not the same. So I'm going to erase those because we don't want to look at them. But I do just want you to notice the distinction. So when I rewrite this, I'm going to be very careful that I copy it down correctly. And we're left with that. So 20 times 11. I know that 10 times 20 is 200 plus 1 times 20. So this is 220 divided by 4 plus 25. So 220 divided by 4 is, let's see, 20 divided by 4 is 5. 200 divided by 4 is 50. So 55 plus 25. And then our answer is 80. So if we look at this, first we did our substitution. And then from here to that step, we multiplied. Here we divided. And then we added. So if you check our order of operations, it looks like we did multiplication so that we could then divide, so that way we could add. So we've followed our pyramid nicely on that one. So in this problem, you begin to see how they get to be more complex. So when we're evaluating this expression for x plus 3, I know because of my pyramid that the very last thing that we're going to do is addition or subtraction. So I can, in a way, think of this almost like it's two separate expressions that we're going to be solving. We have one expression that we need to simplify. Then we have another expression that we need to simplify before we finally add them together in the end. So I'm going to rewrite this, and I'm going to keep my color codes together. We're substituting 3 in for x, so we have 3 plus 1 over 2. And I'm going to substitute 3 in for x on the green side. 5 times 3 minus 3 all over 10. And we know that we still need to add those together at the end. So here I just did my substitution. Now I'm going to work in my numerators because I know I want to divide those entire numerators by the denominators. 3 plus 1 is 4, so we have 4 over 2 plus, and on this green side, 5 times 3 is 13. 13, minus 3 all over 10. So if you notice, I've got my blue or my purple side simplified all the way, so I'm just going to write that down. And I need to do a little bit more simplifying in my numerator side. So, I wrote the wrong thing. Sorry, 5 times 3 is 15. Okay, there we go. So now we have 15 minus 3 that we need to continue evaluating. So we have 12 over 10. And so now now that I have both of those at the point where they can then be simplified, 4 divided by 2 is 2 plus, and then 10, or 12 divided by 10 is going to be 1 and 2/10. So when I add those together, I get 3 and 2/10, which is equal to 3 and 1/5. So there is our answer. So to quick check our steps, on this side we had to multiply, on this side we had to add. This side we had to do some subtraction, and then we did some division. And then here we did some division before we were able to finally add at the end. So we've followed our order of operations, and we have correctly and accurately evaluated these. So that is, let me see if I have any more. Ooh, I have another one. Let's look at this one and see how this one goes. Because this one, again, is a little bit more complex than we have here, but you can see how eventually this will become hopefully pretty straightforward. So our subtraction is going to be the last thing we do. So I am going to keep track of those. And I'm going to evaluate, I'll keep the purple color code as well here. So rewrite and substitute minus, and then on the green side, we'll substitute again. 5 times 16 minus 4 times 3 all over 2. So with each step that I go down, I'm only going to pick one thing really from each color to simplify at a time. So on the purple side, 3 times 3 is 9. So I'm working according to my pyramid. I need to start with my parentheses before I move on down below. So inside of my parentheses, I have subtraction and multiplication. I'm going to begin with my multiplication, and then I'm going to rewrite. Then I'm going to do my green side, where I'm inside my parentheses. I'm going to do my multiplication again, which is 12. So I have 5 times 16 minus 12 over 2. Now you might be tempted to skip some of these steps and just do some of the number crunching in your head. I would strongly recommend not, because as we get into more complex expressions, especially ones that involve negative numbers, it's really easy to lose a negative lose a negative sign in there, or to have a miscalculation, and then you can't identify, or it's harder to identify that you've made that mistake. So back to the purple side. We're still working within the parentheses. I need to do that subtraction, and it is 2. So I'm left with 13 times 2 minus, on the green side, still working in the parentheses, 16 minus 12 is 4. So I have 5 times 4 divided by 2. Back to the purple. 13 times 2 is 26, and we are subtracting in my numerator. 5 times 4 is 20 divided by 2. So then we have 26 isn't going to change, but 20 divided by 2 is 10. So I'm left with 26 minus 10, which is 16. So taking your time, going bit by bit, and really, really paying attention to this bar means I want that entire numerator divided by that denominator. So keep an eye on where that is, because it will be a very small change that can really affect the accuracy of your answers. And that's it. Take your time, work on it vertically, show every single step.